We'll go ahead and get started here. Welcome everyone. I'm Andrew Conley. I'm the Chief Program Officer with Clean Fuels Ohio. Pleased to be joined by Intertrust team today, particularly Chris Kalima and Sung Chun, who are here with us. We're going to be going through a webinar on the Intertrust CleanGrid platform and how it can help inform EV infrastructure planning. So with that, I'm going to touch base a little bit on our agenda today. Obviously making some opening remarks here, but really going to dive in from the Intertrust side into an introduction on their platform, talk about how their platform is allowing multiple data sets to be integrated for planning purposes, hear a little more about Clean Fuels Ohio and how we are partnering with Intertrust on the Ohio front, and leave about 20 minutes or so for Q&A with all of you to have some conversation. So in terms of housekeeping and logistics, please feel free to chat questions into the chat boxes here. We'll be monitoring those. Particularly the Q&A box is the easiest way to get your Q&A across to us. Chat those into the Q&A section while you have them. I'll be the kind of voice of the audience, if you will, voicing the questions to the Intertrust team during the Q&A. So you, I believe, will be on mute the entire time, but happy to be the voice of the questions and get through as many of your questions as we can at the end. So with that, I'd like to turn everything over to Chris Kalima with Intertrust to walk us through the introduction from Intertrust side. Chris?
Thank you, Andrew. Good afternoon, good evening, good morning, everyone. My name is Chris Kalima. I'm the VP of Product Management here at Intertrust, and I'm responsible for our data platforms product. And I just wanted to kick off with a brief introduction about Intertrust Technologies, who we are as a company, some of the motivations behind the Intertrust data platform, a lot of the problems we're looking to solve, some of the problems we see with data being shared in a trusted fashion. In these environments and increasing ecosystem economies that we're seeing emerge, where data is playing a very key role, whether it be infrastructure planning, operations of EV infrastructure, optimizing the grid, smart grid. So there's a lot of really interesting energy use cases. But let me step back briefly and give a quick introduction to the company itself. So Intertrust is a privately held organization. We have our headquarters in Silicon Valley. So we're based in California, but we also have offices in Europe and Asia. We are a leader in security, privacy, and trust for open networks and service-enabled devices. Some of our key innovations and inventions include trusted distributed computing, innovations around digital rights management, securing digital content as it traverses from data owners to data consumers. We've been very active in the media industry. So think about streaming music, streaming movies, a lot of that technology that protects content while it's in transit to consumers was created by Intertrust almost 30 years ago. So we have a long legacy and history in protecting digital content. We have a robust R&D portfolio. We have a research lab with a number of notable researchers, including a Turing Prize recipient. And currently we're active in a variety of markets, including energy, IoT, automotive, as I mentioned, media, consumer electronics, healthcare, and more. And our team is spread out, again, across the globe with an extensive track record in digital security, energy, media, and a number of other verticals. So stepping back and again, looking at the motivations for the Intertrust platform, when we look out into today's IT landscape, we're seeing a number of distributed devices, competing cloud infrastructure, and really disparate data storage architectures. So some organizations are storing data on premises in data centers. Others are migrating to the cloud, storing data in Amazon or Azure or IBM, a number of different cloud infrastructure providers. You have IoT devices that are out there reporting bits of data, whether it be events that they're recording or sensors, or even actuators that are taking action based on signals that they receive across the network. And really, it's a very complex architecture out there, and it becomes even more complex when you start thinking about not just your own organization, but if you start needing to interact with third parties, maybe service providers or other vendors, by providing them data. How do you deliver that data? So some of the problems that we see is really a lack of interoperability. You're seeing a lot of different protocols, data stored in different ways. Again, some of it's maybe on-premise, some of it's in the cloud. How do you get access to that? Because there's the diverse set of different storage mechanisms and architectures and infrastructures, you don't really have consistent security. Data's moving around, it's being duplicated, it's being copied. This leads to data breaches, data leaks. Data may be provided to a vendor and now they have a copy of your data. So you've lost custody of that data. In order to tie all of these systems together, it's typically an expensive system integration. It requires a solution provider typically to come in and sort of tie together 2 or 3 systems. But if you start thinking about the scale at which these ecosystems are starting to operate, it's really becomes quite a challenge when you're looking at introducing a lot more systems and being agile and being able to respond. And as a result, you really have this impossible landscape to govern and produce compliance. We see a lot of legislation that's been introduced. Within the EU, they have GDPR, which outlines the rights of data subjects and what rights they have to the data that's recorded and produced on their behalf. So using personally identifiable information requires consent, and you have to track that through the processing chain. And so complying to these regulations, and we're seeing those emerge increasingly here in the US. California has sort of led the way with CCPA, but we see other states looking to adopt similar legislation. So this is a growing complex landscape, and there's legal repercussions, there's financial repercussions for violating these laws. So it becomes quite a problem to manage. So those are some of the issues that we really wanted to address with the Intertrust platform. We want to create this trusted data interoperability between these different stakeholders. So whether it be a utility who has operations and assets, infrastructure such as low voltage lines, high voltage lines, they understand the power consumption. You have charging system operators, they have their own nodes in the network, these charging poles or charging stations, and they understand how those are being used. You may have automotive companies, OEMs, that have telemetry that's coming off of vehicles. So you might have battery state, you might have GPS location of these, where are these vehicles charging, what is their current charge state. And then you have municipalities that have a lot of information about their specific geography. So it could be land use restrictions, it could be vehicle registrations from the DMV, it could be the location of certain infrastructure like city garages, for example. So all of these stakeholders, if they're able to interoperate and start to share data with one another, our premise is that a lot of this planning, a lot of very interesting use cases can really be fulfilled if you can provide trust, collaboration, and interoperability between all of these different stakeholders. So jumping into the EV infrastructure planning problem and looking a little bit at some of the background, what we're seeing right now is this accelerating EV adoption. And a lot of this is being driven by climate change or climate goals that a lot of cities within the US are looking to meet. And here, as an example, we're looking at San Francisco, and they're targeting 100% EV sales by 2030 as a part of its climate initiative, clean air initiative, clean energy use. And so that means that the number of EV registrations is going to jump from about 20,000 in 2020 to almost 400,000 in 30 years in 2050. And what does this mean? This means you're going to have a lot more infrastructure to support all of these vehicles as they're moving around the city. And it's estimated that around 6 times more charging is going to be needed by 2030 from what is installed in 2019. Now, this is a very aggressive target. Obviously, I think San Francisco is striving and really putting forth a really commendable goal. But you can see this is a real problem. They need to identify locations for EV chargers. They need to actually roll this infrastructure out, incentivize that in order to see and meet these EV adoption goals. So there's going to be this substantial increase in infrastructure deployment. And any city that's looking to follow this path, and Andrew can share a bit more about what's happening in Ohio a little later on in this webinar, they're going to face similar situations and similar problems. And so planning requires data. And again, getting back to that multi-party data problem, there are many stakeholders who might have useful bits of data that could be helpful for efficient infrastructure planning. And so again, it could be city agencies, it could be utilities, charging system operators, even EV owners themselves, who might want to provide input about where they think a charging station might be needed. And this is not a static situation. This is something that's very dynamic. It's going to change over time as demographics change, as adoption increases, and you'll see laggards come on board and start to actually acquire EVs in markets where they may not be early adopters. So over time, cities are going to need to re-examine and adapt to the local conditions as the dynamic changes. And this means they're going to need access to the latest data. This isn't something where you can run a report once and use that over the next 20 years. You're going to want real-time access to a lot of these data. And so again, looking at grid power availability, land availability, the current location and usage of charging infrastructure, this has been a really big obstacle for decision-making and choosing the optimal locations for EV infrastructure. And getting back to that problem, we see that this is actually introducing a lot of soft costs. So procurement of hardware and different requirements to support the EV infrastructure, that's one thing. But communication between the utilities and the charging system operators and some of these hidden soft costs are actually pretty significant. And it's caused significant delays and maybe forced operators to rework plans because they're looking at a specific site, they're generating a plan to actually deploy there, and then after weeks or months of back and forth with the utility, they come to find out that a location isn't actually feasible. Maybe the infrastructure can't support the amount of charging infrastructure they want to put there. So the transformer, there needs to be additional resources from the utility side put out there, and that's a significant cost, and that might blow the project up and put it over budget. And so what we're seeing are charging system operators will typically look at multiple sites. This increases the complexity. Now they have to plan for multiple sites. So it's really causing a lot of these soft costs, and they can be significant. And now if you're able to communicate the grid capacity in a very efficient way, and what would actually is required to get this utility interconnection, so facilitating that communication between the charging system operators and the utilities to speed that process along, we can help to eliminate some of these soft costs and also speed the time to deployment. So help with the overall expenses and also with the adoption period, so shortening that timeline. And now this is a real thing. There's money that is being allocated here in the US. Yesterday, Biden signed the infrastructure deal. So this has become, now the faucets will turn on and money will start flowing to states very soon. So there's $7.5 billion that's been allocated to build out this national network of EV chargers. $5 billion of that is focused on highway charging, and that will be rolled out over the next 5 years. And now that this bill has been signed into law, there's about $1 billion that's ready to be distributed to states, and that's expected to happen within the next 2 to 4 weeks. But states won't be able to spend this money until the transportation department sets out some criteria for plans and an approval process. So we're looking at a timeline of around 6 months where money will actually begin to flow, and a lot of these projects will receive the funding to proceed. But obviously, having the ability to plan and designate sites and identify the most viable sites will be critical in getting some of that funds and proving, proving to the states and the federal government that these are good investments. And so the Intertrust CleanGrid is a solution that my colleague Sung will demo in a moment, but it's really this digital toolkit for the clean energy economy. And it builds on top of the Intertrust data platform using a lot of the underlying technologies around, including data virtualization, identity and access management. We have a time series database, secure execution environments. We use these technologies that the platform provides to develop a vertical that's useful for planners who are looking to roll out EV infrastructure. And so it packages all these features to help the utilities meet their customers' clean energy transition goals. It also provides applications that are suitable for EV data operations, grid data operations, and even retail data operations. So use cases where data needs to be shared with other stakeholders in the system, the Intertrust CleanGrid solution can help govern that data and distribute it to different data consumers who can then use that in a variety of ways. And EV infrastructure planning is just one example of this application and use cases. And so with that, I'll hand it back over to Andrew, and you can share a bit about Clean Fuels Ohio.
Great, thanks for that overview, Chris. Obviously, many of you on the call know Clean Fuels Ohio, and for those who don't, Clean Fuels Ohio, we are a nonprofit. We are a US DOE designated Clean Cities organization, and our mission is to help fleets and motorists adopt cleaner, more energy efficient and sustainable vehicle technologies. We do work inclusively across all the commercially available alternative fuel vehicle and efficiency technology portfolios here in the state of Ohio. If you jump to the next slide, as I mentioned, we are a U.S. Department of Energy Clean Cities Coalition. That means we have peers all throughout the country. So for those of you who are national, I do see a couple of our peers in the attendees. You know, if you're working with stakeholders in any of these regions, really encourage you to connect with our Clean Cities peers across the country to really rely on that national network of expertise and key partnerships on projects and opportunities. Here in Ohio, in terms of work with Intertrust, if you jump to the next slide, Chris, we're really working through our Drive Electric Ohio program, which features, you know, a multifaceted set of pillars here that you can see running down 1 through 7, where we have aspects of this program focused on grassroots consumer education. We work with local, state, and federal policymakers on education, both policies and planning, which the Intertrust CleanGrid platform helps you inform. We're working directly with a lot of utilities and see this as having a lot of application there. Obviously, our bread and butter historically has been with fleets, and we continue to work on fleet electrification projects. But 5, obviously, the charging station infrastructure planning and development. We really see the CleanGrid platform actively informing some of our work right now, which we're going to get into next. And then we also are really focused on dealer and manufacturer engagement, as well as ensuring equity and access as the market grows here. So with that, I'm going to turn it over to Sung, who's going to give us some live demos of the CleanGrid platform, as well as showcase some of the ways Intertrust and Clean Fuels Ohio are working on planning in Ohio. Sung?
Mm-hmm. All right, cool. So let me share my screen, asking all these weird questions. Sorry. You should be able to see a map of the Bay Area, San Francisco Bay Area. So again, this is a quick demonstration of the CleanGrid solution. This is built on top of the Intertrust platform. And what I'll be demonstrating here is how you can share, different parties can share their data, securely share their data, and then how you can generate new insights once you have access to a variety of data. So again, this is a simple GIS system. Some of you on the call might be familiar with this, but the main focus here is more around the sharing of data and how you can govern access to your data. Right now we're in the Bay Area, San Francisco Bay Area, and we have a variety of different data sets that we've incorporated into the platform. And keep in mind that we don't need to copy any of the data over to the platform. Basically, the data can reside where it's hosted. So it could be on a cloud, it could be on-prem. So regardless of where you're at, we could connect the data to the platform, and then be able to interact with that data. So for example, we have some public data. This is the existing EV charging stations throughout the state. We also have some of the electric substation and power plants that are publicly available. And then finally, we have some public high voltage transmission lines throughout the state as well. So this is just some public data incorporated, but we also have access to some of the third-party data. So here in the Bay Area, PG&E is our local utility. We have been granted access to some of their data as well. So here's the load capacity lines throughout the city of San Francisco. Again, this data can be provided, and they can govern access to all of the data. So right now we have access to the Bay Area, but as a data owner through our platform, you could even restrict access to small neighborhoods or even the city or even street level. Beyond this, we also have some PV hosting capacity lines. Identify how much load we could additional load we could put on the grid, and then we also have feeder level distribution generation data as well. Beyond this, we also have data coming from the municipalities. So, for example, we have all the parking structures throughout the city of San Francisco. This could be data that's owned by the city. We also have the private garages that are tied to individual households throughout the city. And then finally, you might be working with a lot of data providers, data vendors who have their own set of data. So we could also incorporate their data sets into the platform. And again, so one of the key features here or benefits we have by doing this is, again, you could interact with all of these data together in the same platform. So let me go through one of the use cases we have here in the city of San Francisco. Recently, there was a mandate or requirement where all of the garages, public garages throughout the city of San Francisco would need to convert at least 10% of their parking spaces to EV charging stalls. So the challenge that the city had was how can they work with the PG&E and also with the garage owners to identify which ones they can easily adopt and transition over to EV charging stations versus those that would require some additional system upgrades. So when we combine this data with the existing PG&E data of the load capacity, we could quickly help the municipalities identify which of these garages can immediately adopt EV infrastructures, whereas others we could phase out and potentially work with PG&E to upgrade and install those at a later point. But again, this system right now we're looking at 10%. What happens in the future if they increase that to 20% or 50%? Again, the same issue comes across over and over again as the EV adoption continues to grow. Now, another use case that we're working with a lot of the utilities and municipalities right now is, what happens eventually at some point, all of these homeowners decides to buy an electric vehicle. Eventually, they're all going to install a charging station inside these garages. And so, again, what is the impact to the local grid when every household eventually buys one or more electric vehicles? So again, this is a tool where they could potentially predict what might happen in the future and hopefully plan out. So they could identify hotspots in the grid and either introduce some sort of local storage or maybe either upgrade the infrastructure altogether or maybe introduce some sort of a scheduling program where these homeowners can only charge their vehicles at certain time periods. So again, this is just another way of where you combine the different data sets from different providers and then being able to generate insights into what might happen in the future. Now, one other challenge that the municipalities and the utilities face right now is also identifying where to install these charging points. This is the same issue that Clean Fuel Ohio is also addressing. Again, we have the obvious places, maybe near shopping malls, maybe near parking lots, near the freeways. But beyond that, you're kind of guessing on where to install these. And so a couple of ways that we could provide capabilities within this CleanGrid solution is working with other data vendors. So we're currently working with potentially working with the auto manufacturers where we could get some anonymized vehicle data. And if you think about this concept, it'd be nice to know visually on a map where a majority of these vehicles are parking throughout the day, and then being able to overlay that in conjunction with the existing EV infrastructure and seeing where there are gaps. So maybe you have a lot of EV vehicles parking here throughout the day, but there's no charging infrastructure nearby. Again, this will help you generate these hotspots or heat maps where the utilities and the municipalities can focus on maybe upgrading some of the infrastructure at that location. Another one I'll showcase a little more in Ohio data, but again, you could also look at the DMV electric vehicle registration data. You can start generating heat maps of where majority of these EV owners are located, and in conjunction with the existing EV infrastructure. And the last piece you could potentially also offer within the CleanGrid toolkit is the ability to open up this to your residents. So you might have EV owners throughout the city, and you could ask them to come in and ask them to put ask them where they would like to install these EV charging stations. So they could drop a pin on the map, add some details, maybe some screenshot or photoshops of the area, and you could start crowdsourcing this information. So multiple people could potentially like the same location. And so just another way for the utilities and municipalities to gather information on behalf of their consumers. Now that you've collected all this information, the next step, I won't be able to demonstrate this here today, but we also have partners in the CleanGrid toolkit that does real-time grid calculations. So theoretically, we could share a localized data points of the grid, utility grid. We could also share the local consumption patterns of that local grid. And then also the details about what asset we're going to install at that location. And then literally in minutes, we could come back and the system will come back and return whether this location is viable to actually install that load without any infrastructure upgrades. So this process typically takes weeks to months for the utilities to respond back to, whereas with the system, we could quickly identify all of those locations that can immediately support this additional load without any infrastructure upgrades. I think that's a huge time savings in terms of just being able to identify and then go through that process. So let me switch over to the other demonstration. This is the demonstration of the state of Ohio that we've been working with alongside with Clean Fuels Ohio. And some of the data points that we have here, majority of these are public data, but it'd be great if we could also work with some of the partners here and be able to identify some additional data points that could integrate into the system. But here's the I-80 Turnpike. We just highlighted that on the map. We also have some of the public transmission, high voltage transmission line data throughout the state. We also have the substation data throughout the city, throughout the state. And then we also have the existing fuel stations, whether it be electric, hydro, or biodiesel, any type of publicly available data on all the different alternative fuel stations that are available. We also have, as I showed earlier, we have the EV registration data as well. So you can identify hotspots of where a majority of these electric vehicles are being purchased and registered. And then finally, one of the other data points that's pretty interesting is the average daily traffic throughout the roads. So again, you can quickly see which roads are being heavily utilized throughout the state as well. Again, all this is most of this data is all publicly available data. And then finally, I forgot to mention there's also the fleet network data as well. We can identify all the various fleets that work throughout the state of Ohio as well. Now, one thing I want to quickly demonstrate here is the governance aspect, how you can share your data. As you mentioned earlier, you as a data owner can control all aspects of your data and what people can see of your data. One example of this is the substation data. Currently, we have access to all the data across the whole country. But what we've done here is we've created another layer. You see this Ohio substation. It's basically pointing to, it's the same data set. We're pointing to the same data. However, through the platform, what we've done is we've created a filter or a rule that says you can only access the data that's within a geographical boundary. So for example, here, I'm only allowed to see the data that's within the state of Ohio. And it's a similar concept of just filtering out the data. You create a rule that says only return data within a certain region or based on certain field values within your data. Or in this case, we're doing a geographical boundary. But you have full control over this within our platform in terms of what access users have when you share your data. And so again, from Clean Fuels Ohio's perspective, they're working on this I-80 initiative. They could use this data. They have some of the load capacity maps. We could probably potentially look at that at a much more granular level. Currently, we only have these high voltage lines, but you could also combine that with some of the alternative fuel station data and maybe even the EV registration data, and be able to generate these forecasting in terms of where we should potentially install these EV charging stations throughout the I-80 corridor. And the last piece I want to just quickly demonstrate is more around the analytics side of things. So here's another use case where we have, this is more on solar data. What we have here is a city where we're working with another data provider where they provided all the solar information. So in this city, we could identify which rooftops are suitable for installing solar panels. So again, this data is coming from a data provider. We also have some data coming from the utilities. And when we combine this, we can start doing and generate some KPIs within our secure execution environment. Basically, the data never is exported from the platform. Instead, you bring your algorithms to the data. And in that scenario, you could generate these type of calculations. So for example, here in this city, 56% of the rooftops are suitable for installing solar panels. Now, if we did install solar panels in all 56% of these rooftops, we could potentially generate 1,000 gigawatts of energy just off of solar. And that translates to about 535,000 metric tons of CO2 reduction that we could potentially support by just converting over to solar. Again, these calculations can be done within the Intertrust platform, where you don't have to send a copy of your data out to other vendors. And that pretty much concludes the demonstration. Andrew, maybe I'll hand it back to you.
Yeah, thanks, Sung. And I think a couple of key things I'd highlight from my perspective, and then we can open it up for questions and answers and more discussion on the tail end here. So certainly there are a lot of different platforms to chunk in static data sets and visualize data, like you mentioned, ArcGIS and a whole bunch of other platforms that even Chris highlighted. But both the interoperability as well as the security are really the unique features from my perspective. And certainly Clean Fuels Ohio has been working on a number of projects that have required data sharing agreements and just a very complex set of legal conversations to even get key data sets. And those have usually revolved around ultimate data security on a platform or server, and then some form of anonymization of that data before key audiences or use cases have access to it. And then that's usually granted in some kind of basic login, log out kind of user interface to that fully anonymized data set. So from my perspective, and certainly Chris and Sung, you did a great job speaking to this, but I am not a data specialist, nor am I a cybersecurity specialist by any means. So it's kind of hard for me to wrap my brain around all this, but the streaming analogy is a pretty good one in my mind, where we're all used to having some form of either Netflix style media streaming or Spotify style audio streaming, where my physical device may have access to some portion of that song or movie, but then I don't actually own the movie in any way or have the movie. So I'm very interested in the Intertrust platform personally and professionally, in the ways that those kind of data and cybersecurity issues can be solved for in this interoperable platform that basically doesn't just grant broad user privileges, but keeps the data on the home servers of the data owners, particularly with projects around EVSE. Getting utility grid capacity maps is, kind of a holy grail and a really hard thing to do in the age of homeland security and infrastructure threats. There are very necessary checks and balances to how that data is shared out. But if the utility chose to opt into a platform like CleanGrid, obviously Sung was visualizing what that would look like down at the very granular, intersection level in San Francisco. So we're certainly working with some of our key utilities to forward conversations around that in Ohio, and certainly see the Intertrust platform, not just its interoperability and some of its analytics, but particularly those cybersecurity features as critical enabling features that will allow for more of this planning in real time with multiple users and use cases accessing different levels and details of given data sets. So in my mind, that's a real value add. So really appreciate the work we've been doing with Intertrust and looking to get more data sets into the platform for Ohio to solve for some of those things. With that, that's kind of my high level 2 cents, but happy, Chris or Sung, if you have anything else to add before we open it up to questions and answers.
Yeah, no, nothing. I think you summarized it pretty well, Andrew. And again, I think for us, it's really, we're seeing this emergence of these multi-party systems with regard to data. And it's becoming really interesting to see some of these use cases because organizations internally, historically, have really struggled to manage their own data, share it within their organization. And that's definitely one of the use cases for the Intertrust platform. But I think what really is exciting is looking at these larger ecosystems that are emerging. And utility is one space, but we're active in other sectors where we're seeing this. There's use cases in healthcare where you might be doing a clinical trial and you need to interact with multiple hospitals, and there's a hardware provider that has a certain medical device and maybe some pharmaceutical providers, and that's obviously a huge personally identifiable information minefield in healthcare. But if you can enable the people to share this data, get access to this data, remove some of these roadblocks, you can really accelerate what can be done. And so that's really one of our main focuses here at Intertrust. And we see a lot of exciting opportunities when you can enable these ecosystems.
Yeah, and Chris, to kick off the Q&A, I know there are like other platforms like Data Lake and different things that we've referenced. Maybe you could describe a little more how Intertrust is different from those.
Yeah, so I think Sung sort of touched on it. I mean, and this may be a little bit more of a technical deep dive. I'll just give a quick bit of a summary here, but you'll hear about technologies like a data lake or a data warehouse. Typically, these are being used as mechanisms to store data, and they have certain attributes that make them useful for certain users. So a data lake is typically a repository where raw data is being captured and made very accessible. You typically don't know what you're going to be using that data for. There's some hypothesis that this data might be useful in the future and we need to capture it. And so a data lake is really useful for data scientists. It has raw data. They can do exploratory use cases there. And it's typically very low latency. So that data becomes available immediately. There's large volumes of it. But it's typically not structured very well. There probably hasn't been quality controls done on it, and a lot of work to ensure the veracity of that data. A data warehouse, on the other hand, is typically a repository where data is undergone some quality control process. There's typically a known business use for that data. It's usually structured into a way where business users can create dashboards, create reports, and so it's very reliable. But as a result, it can be very difficult to modify. Getting data into it requires typically an ETL pipeline or some type of data processing pipeline to load that data into your data warehouse. But it becomes sort of the centralized repository where a business can target a lot of its reporting capabilities. And so you might see a business analyst creating a Tableau dashboard or some type of BI tool, using a BI tool like Power BI, to generate reports and publish those to other management stakeholders. So you see both of those sort of technologies, they service different people, but with the Intertrust, we sort of blend that into an architecture that's a little bit more emerging, that's called more of a data lakehouse. So it sort of has the benefits of each of those. And as Sung mentioned, we are not a data repository. So the platform itself is actually, you can think about it as a layer that can come in and provide this interoperability over existing infrastructures. We don't want to force our customers to move all their data into a centralized repository. So if you have a relational database, you have a data warehouse, you have data lakes that are being used and are fit for purpose for those different data consumers, the platform can actually connect to those and allow you to create data sets from those underlying data stores and then publish those out to different data consumers. So that's where that governance, the data virtualization, and the secure execution environment, which, as Sung mentioned, allows you to retain custody of the data. We don't actually distribute the data out, but the algorithms and the workloads can come onto the platform, run against data, produce some type of data product, whether it be an insight or some machine learning model, something that creates some value from that data, take that product out, but the raw data is retained by the data owner and doesn't egress outside of the company. And one of the use cases I like to sort of highlight there is Facebook with the Cambridge Analytica data breach, right? The Cambridge Analytica signed a contract to use the Facebook APIs to not store data that they were acquiring over these APIs. They violated those contracts. They stored data. They used it in inappropriate ways. And that was because that data was actually being published out through those APIs. So they were able to copy it, retain a copy of that data. And as a result, there was tremendous reputational damage for Facebook as a result of this data breach. So that secure execution environment feature of the platform allows you to retain custody of your data. And so I think there's a pretty unique feature set there. And again, we really want to bring all those together to then allow different verticals to use those technologies to connect their data and develop applications that fit their use cases. So we are not domain experts in all these verticals, but we want to enable domain experts in these different verticals to take advantage of this data.
That's great. And it looks like we have an attendee that has their hand up. I don't think we have, I know I don't personally have the ability to grant folks open mics here. So if you are looking to ask a question, please either chat that in the Q&A box or the chat panel. But certainly, Chris, yes, that data virtualization and the fact that it can't be copied out. I think I heard one of your team members kind of describe it as maybe a too on the nose pandemic metaphor, but like the medical institutions where they have that hermetically sealed box where you can put gloves in and manipulate things, but you can't take anything out. That really kind of keyed off some of my less technical dots connected in my brain. So like, I think that to me is a key feature that will enable, potentially multiple users like a utility with their grid capacity data to not have to fear that that's going to be, a genie out of the bottle, but that it can be fully stored and they retain custody of it and allow more access. Curious more about the, question here about the analytics platforms that you're alluding to, Sung. Can you speak more to some of the key analytics that can also be added on top of the platform?
Yeah, so there's a couple of ways we could integrate with analytics tools. So, we ourselves act like a database. So if you have tools like Tableau, you could actually connect that to our platform, gain access to all the data, for example, the one that I demonstrated earlier, and then being able to run your own analytics on that data. So again, we have the full capability of being able to connect third-party applications to the platform, but we also have, in the scenario where you don't want to ever have your data be egress from the system, that's where we can actually provide an environment where the analytics can come to the data. And that right there is a little bit different where we allow the data to be only accessible within this environment. And then so basically the data scientists or analysts, they could upload their programs into this environment. The environment accesses the data. It does some analytics on that data, and then it could generate output of that from that raw data. Now that output can also be converted into another data set, and then you can also govern access to that data as well. So maybe there's still some private information that you don't want to expose, or there might be some confidential information. You could also govern access to the data that was just generated by your algorithms. So there's two folds again. One is by just connecting your clients' AI tools directly to the platform, or in other scenarios where you don't want to expose your data, you can bring your models and programs into the data.
Great. So a couple more questions coming in from the audience here. One is Hung from Energy Hunters, says, my inquiry is if we can merge some data sets like solar generation, EV usage on our sites, and as well as grid electricity prices. Can we commission an AI model that can be developed from this to develop insights that we can start using from the EV sites and our clients' data?
Yeah, for the first part of the question, you could generate, once you have access to data, you can start creating virtual data where you merge cross different data sources. So regardless of where the data resides, you might have one table in Google Cloud, another one in AWS. You could actually virtually create a virtual data set inside the platform, and you can start doing cross joins across that data, all within the platform. And again, in terms of the AI, again, once you have access to that data, you're free to generate any type of models that you like. Again, it depends on what data is available, how much data that you need, but you could definitely create models against a historical view of their data. And again, if you don't want that data to be ever exposed out of the system, you could create those models within our secure execution environment, where you can gain access to a lot larger time set series of data, use that to train your models, and then potentially also test your models within that environment as well.
Great, thank you. Another question here on how granular is the EV location data at the times when charging is likely? What is the source of public charging locations or personal vehicles or fleets, battery depletion, public or private? So question on EV charging location and type data sources.
Yeah, so this goes back to more of the data providers. It's all ultimately owned by the owners of the data. So if you're working with the charge point operators, for example, they might be able to provide you with much finer granular data sets. So again, we don't provide the data ourselves. Our platform basically allows you to share that data across different entities. Maybe Chris, you had some more comments on that.
Yeah, no, it depends on the data owners. I mean, I think that's one of the main premise of the Intertrust platform. So we've worked with utilities who have provided a lot of this information. As Sung mentioned, we have some work that we're doing with an automotive OEM who is interested in sharing some of this data with some stakeholders. So that includes anonymized, sort of clustered automobile data, so that you can actually, so that it addresses some of the privacy concerns around individual vehicles, because tracking those allows you to discern a bit more than you probably should be able to. So having some clusters of vehicles and what their battery state is, and the granularity of this in terms of like temporal resolution is probably on the order of seconds, if not less. So it depends on the data that these organizations want to publish. And so we want to make it really easy for the data owners to provide it. Now, that relationship is ultimately up to the parties to work out. And so that's one of the things that we want to make it easy for these data owners to share their data, so there's less data friction and they're more willing to share this. But ultimately, Intertrust, we don't own data, we don't produce data, but we facilitate the interoperability of data. So that's really the role of our software in this relationship.
Yeah, one thing I want to point out here also around privacy, a lot of these data providers might have confidential information, like as Chris mentioned with the hospital data. And with our platform, we have the capability to obfuscate that data. So you might want to potentially share some of this information, but not share the actual raw information, raw details. So within the platform, you could either obfuscate some of the data, anonymize some of the data. So at least you could still work on that data, but not be able to identify who the actual end user is of that data.
Right. So like if we try to take that same process into the EV and EVSE world, there could be data from a company like ChargePoint. If they opted in, that would still be stored on ChargePoint's own network with its own security. And they could say, okay, we're going to grant DOE National Laboratories a lot more detailed access but then we're going to grant certain research institutions slightly less detailed access, and the general public a much more anonymized data set. So like that same raw data could be parceled into different access points or different end user audiences based on user agreements that ChargePoint would have with all those different audiences, effectively, is what I'm hearing you say.
Correct. And in that scenario, you don't have to make multiple copies of the same data
Right.
to address that. You just have one set of the data. You just add the different rules on who can access that, what part of that data.
Right. And not only not having to have multiple copies, but ChargePoint never even has to transfer that data out
That's
of their
correct.
own.
That's correct.
servers.
Typically right now, a lot of people export into CSV and send them a copy. And at that point, you've lost custody of that data.
Right.
Right.
Yeah. And that's really, with data sharing agreements that we've been working on with fleets and utilities and others, that's just a big sticking point of not just the getting all the legalese worked out, but even if you get all of that worked out, you've been given a one-time static view into this, or an API with some security concerns. So I think, from my standpoint, you're solving for both of those things. Well, great. Certainly you're mentioning, obviously your demos have highlighted clear use cases around solar and EVSE. You're also highlighting, there's wide variety of other potential use cases. Is there anything else you'd want to flag in terms of kind of creative uses of analytics or data integrations?
Yeah, I think the one that Chris mentioned right now, health, is definitely another hot topic. Just being able to share data from a confidentially share data from a health perspective. And again, EVSE is one, but we're also looking at other, smart homes. There's smart grids. There's a bunch of use cases that can be applied here. Right now, today's session is more around the EV industry, but the same concepts apply for a variety of verticals.
Yeah, and certainly in the transportation realm, there's an increasing push towards smart, connected, and autonomous vehicles, which touches on kind of the clustered data from OEMs that I think Chris was referring to, and certainly whole new fields of data from connected and potentially autonomous vehicles.
Yeah, well, I just want another point to add. I think you're seeing companies that are traditionally active in one vertical potentially moving into others. And so we've been active with insurance companies looking to figure out, and you've seen this with some different insurance products that have sort of come out that are parametric insurance. So like ensuring that your flight won't be delayed. And they're using real-time flight data, and you can take a very small policy out, and if it's delayed more than an hour, they'll pay you X dollars. And so there's a lot of interesting settlement triggers that can be sort of built into the insurance industry. They're also looking to gain more insight into their customers. So coupling maybe a mobile app that if you enable, they'll give you a reduced rate because now they can actually monitor the telemetry and how you drive. Now, that may or may not be appealing to you as a driver, depending on what type of driver you are. And there's typically a lot of kickback around that when traditionally you had to install a little device in your car. But that does allow people who exhibit good driving behavior to get incentivized with lower insurance rates. And actually, I think Tesla recently just rolled out its own insurance policy. So it will now insure your car in Texas. And because they have all of the information, they're fully vertical. They know what the vehicle is doing. They can see what you are doing when the vehicle is doing things, if it's accelerating rapidly, braking rapidly, where you're traveling. And so they're creating new products on top of that. And actually, that was one of their prerequisites for enabling this auto driving feature. So you needed to be vetted by its AI, which would evaluate if you were a good driver in order to enable the autonomous driving feature. And so you're starting to see it if you have access to the data, right? I think Tesla's a very interesting use case because they're so vertical and they control a lot of this within their own environment. They have their own charging networks. They have obviously a car that's completely outfitted with all kinds of sensors. And so they're able to actually sort of lead the way into these new domains. And what we want to do is enable other companies to do the same. They may not have all of this data themselves, but there may be a collaborative that can come together to produce these new business models. And so, yeah, you're starting to see this, and it will only become increasingly more data driven.
Yeah, certainly data is crucial to the world and the way it works now and increasingly going forward. So I know we're coming up on our hour here, so I wanted to thank you, Chris and Sung, for your presentations today. Any last minute questions, we can still get a buzzer beater in here, but I'll be monitoring that in the event that there is not any more questions. Are there any last closing remarks that either of you want to make?
Thanks for the opportunity, to share.
Yeah, I think for me, it's just it's great to be able to showcase what we built here and how we can help a lot of the companies like Clean Fuels Ohio to help kind of engage in this industry. Yeah,
and from my part, it's certainly been great working with the Intertrust team and look forward to the continued collaborations. It's as I've said repeatedly throughout this, I am not a technical data expert, but the more I've been actually in the weeds with the Intertrust platform, the more powerful it's become in my mind. So I've appreciated the partnership and look forward to the future of these kind of data platforms. So thank you all for attending today. We'll be happy to follow up. Obviously, you can see all of our contact information here and would welcome further conversations with any of you on the EVSE planning and deployment fronts on the Clean Fuels Ohio side and all the great ways that Intertrust can add value on their side. So thank you all and have a great rest of your day.
Thank you.
Thank you.